Welcome everyone, I'm Adam. In this problem, we're going to be finding the generating curve given the equation of a surface of revolution, which we have here as x squared plus y squared minus 2z equals to 0. So to start with, let's take a look at kind of the standard form that we would have of an equation giving us a surface of revolution. So we see an x squared and a y squared. So we know that we have an equation looking like x squared plus y squared, but equal to, say, some function r of z quantity squared, where this r of z is what we call, right, our radius function. And the radius function is what's going to get us our generating curve. Now, also looking at this, if we have x squared plus y squared equals r of z, if this is a function of z, that tells us our axis of revolution is going to be the z-axis. So now how can we use this? Well, essentially we're going to take the equation that we're given and try and rewrite it so it's in this form. So let's take, right, we have our x squared plus y squared, and we want to get some function of z squared on the other side, so we'll start by adding 2z to both sides. So x squared plus y squared will equal to positive 2z. Now I want to write this as something squared, and that's not too bad. We can do that. We'll have x squared plus y squared, and so this will be equal to, we'll simply take the square root of 2z quantity squared, where this square root of 2z is our radius function. Like we said, that's what's going to get us our generating curve. Okay, so where do we go from here? Well, we have this r of z, a function of z is the square root of 2z, but we need some generating curve. And what we do to get that, right, is we look from our equation in 3 variables, we look at the trace, right, or drop one of the variables out to get an equation in 2 variables. And so we're going to actually get 2 possible generating curves. The first, if we look at this equation, and if we let, say, x be equal to 0, what are we left with? Well, we have y squared is equal to our quantity square root of 2z squared. Okay? And so to get a generating curve, we're going to solve for y. Simply going to take our square root of both sides. So we get square root of y squared is equal to plus or minus the square root of the square root of 2z squared. Now, this is going to give us y. Technically, we could take the plus or the minus, but since we have that our rz is square root of 2z, or the positive, we'll just take that. So y is equal to positive square root of 2z. All right? So then what do we do with this? Well, like we said, this is one possible generating curve. So coming over here, so taking a look at this, y equals the square root of 2z. So the z-axis, right, z is going to be our independent variable, and y is our dependent variable. So the square root of 2z, looking something like the square root of x curve, but going out along the z-axis, will look something like this. And we're just going to sketch it. So starting at our origin, coming up looking something like that. So that's our one generating curve, y equals the square root of 2z. And of course, as we said, our axis of revolution, this is being revolved around the z-axis. So if we revolve this around the z-axis, we're getting some type of a 3-dimensional kind of cone or bowl shape. So like we said, that's one generating curve. Now another generating curve, coming back over here and looking at the trace, if we look at our equation in 3 variables, if we say let y be equal to 0, well, that gives us, say, x squared is equal to our quantity square root of 2z squared, right? And doing pretty much the same thing, taking the square root of both sides. So leaving us with x, technically plus or minus, but again, we're just going to take this as the positive square root of 2z. So that's our second possible generating curve. X is equal to positive square root of 2z. And so if we look at that over in our curve, sketching, or in our plane, sketching the generating curve, so x is equal to the square root of 2z. Well, z again is the independent variable, but x is our dependent variable. So we're pretty much going to have the exact same curve we have here, but projecting out in our xz plane. So again, starting at the origin, coming out here in our xz plane, this will be our curve x equals the square root of 2z. Which again, if we rotated this around the z-axis, we should be getting that same type of three-dimensional cone or bowl shape like we said. So there we have it, our generating curves for our surface of revolution. Thank you very much.